My aerospace engineering degree dissertation could have saved this pilot's life. You see, this aircraft just crashed and it killed this pilot in the process. Did you know that over the years, this exact aircraft has taken the lives of more than 56 pilots, and this just made it 57. This aircraft is called the CL415, and it is a specifically designed aircraft just to be able to fight fires, and the way that it works is pretty cool. You see, the reason fighting fires with aircraft is so dangerous is because these planes have to fly so low over these raging infernos, and the air that comes up from these infernos pushes the aircraft, because you can imagine they're letting go of water, they're flying over this inferno all at the same time, they're changing their physics and their dynamics all in an instant, and sometimes they lose control. This process is dangerous, but there's a simple way to overcome this whole problem so that it's not as dangerous anymore, and it's pretty simple. The process is just to remove the pilot, and that is exactly what my dissertation for my aerospace engineering degree was all about. How do we get firefighting aircraft and turn them into drones? And there was a 3-step process of how we were able to design these drones and make them work. Step 1 was actually designing the aircraft itself. You see, this was the final design that I actually came up with, and the process of actually getting to this design meant I had to design the shape of the hull, I had to design how wide the wheels were going to be, I had to design the placement of the actual engine itself. I had to think about everything. But once the actual aircraft was designed, then step 2 was I had to actually design the scooping mechanism. This is where I spent the bulk of my time. How can we effectively be able to collect water from a nearby lake, store it up in a container, and then be able to deploy it wherever we need to deploy it? The actual mechanism of scooping up the aircraft was a massive deal. Let me show you how I done that. To design the scoop, I had to come up with 3 separate designs and try to figure out the physics of each and every one of them and how that's going to actually affect the aircraft while it's mid-scoop. And once I chose a design, I had to then think about the flow rate of water coming up into the tankers. I had to think about the materials I was going to use to actually create this scooping mechanism so it doesn't break mid-operation. I even had to think about, while designing this thing, how I can make sure that the forces of the plane don't mean the whole aircraft just dips, nose dives straight to the bottom of the lake. All this stuff had to be taken into consideration. Now once I had the aircraft and the scooping mechanism, then I had to think about the shape of the hole that was going to let water out in order to extinguish this fire. I had to think about all the different variables, including gravity, including the shape of the hole. That means it can create a steady stream of mist and water that comes down that's heavy enough to extinguish the fire, but also light enough that means it spreads over a massive amount of area so that we can actually extinguish as much forest as possible with every single drop. And you see, these drones wouldn't do it on their own. They'd work as fleets and then go on and on and on all night, going from a local lake to the fire continuously in order to extinguish these forest fires. And that is how